About 15 months ago, I made a video called "Can I Change the Mind of This Globe Denier?" in an attempt to try and convince a flat earther that the world wasn't in fact flat. Now at the time, SeekTruth Speaktruths had already been having some doubts about his flat earth ideas, and I think my video was perhaps one of the last straws that broke the camel's back and made him realise that he was in fact wrong. Today I'm going to make a similar video for a YouTuber called Rachie. Not because I'm arrogant enough to think that I can convince her the earth isn't flat, I know that's not true, but in the hope that just like SeekTruth Speaktruth, she has been listening and evaluating and thinking about all the fantastic advice she's been given by other creators, and once again, maybe, just maybe, this video can act as one of the last straws to break that camel's back. So as you might have guessed, this isn't going to be my normal type of video, so if you're here for the funny jokes, the editing, the otherwise almost genius level of video making that you're used to on this channel, maybe this one isn't for you. This video is all just for one person.
This video is going to be about where I am in flat earth, globe earth, why I believe it's flat, and my explanations for that.
Now Rachie knows I'm going to make this video, and the one thing I'd say to you, Rachie, is however long the video is, however many sessions it takes you to get through it, please stick with it and watch it start to end. Hopefully there's a lot of information in here that's really going to help you, and from what I've heard from other creators, you really are an honest, quite inquiring mind, so I'm going to be really interested to see what you make of this. Anyway, let's begin by having a look at one of your first questions.
So, I originally came to flat earth because I thought gravity isn't real. And if gravity isn't real, then you can't be stuck upside down into a ball. If gravity isn't real, then why do things fall? So then I started to think, well, things fall because of density. So what's the difference between hydrogen and helium? And everything else pretty much. Density. So more dense down, less dense up. There is, I think, definitely a downward acceleration, because this is hard to explain, but you've got like the 9.8 meters per second squared in the vacuum, and that number comes from somewhere. It falls at that rate for a reason. I'm not sure of that reason.
Now I'd really like to think it's as simple as once you realise gravity is real, everything else will just fall into place for you. And the fact that you understand that we do have a 9.8 meters per second squared acceleration is a really good start. And of course, without a force, according to Newton's first law, which we'll get onto later on, you can't have an acceleration in the first place. However, let's start by looking at why some flat earthers don't believe gravity is real. So number one, some flat earthers will tell you that gravity isn't real because it's only a theory and it's never ever been proven. And it doesn't matter how many times you tell them what I'm about to tell you, they'll just repeat that mantra over and over and over. You see, when we use the word theory in our everyday lives, we kind of mean like a guess or a hunch, something we've got a feeling about but not a great deal of evidence for. But the fact is that simply does not fit the scientific definition of the word theory. You see, in science, that hunch or guess will be our hypothesis, and only when enough evidence has been gathered to really strongly support it can we move it on to a theory. Now, as more experiments take place and more evidence is gathered, the validity of those theories are tested against prediction. Can those theories actually predict what's going to happen in the real world? And if these predictions don't validate the theory, then the theory needs discarding. So to be a scientific theory is a very important thing. It means that you have been tested, you have been verified, you have provided evidence and predictions that come true in the real world. So if you choose not to believe in gravity, fine, but please don't choose to believe in gravity because somebody said it's only a theory. That's not acceptable, and the flat earthers who are pushing the "it's only a theory" argument will never actually admit to understanding what a scientific theory actually is. But what they will do is complain that it hasn't become a law. Except it is a law, the universal law of gravitation. Think of a law as the thing that you observe over and over and over and over again. If you drop a tennis ball, it will fall to the ground. And you could drop that tennis ball 1,000,000 times and it will fall to the ground 1,000,000 times. The theory is the explanation for that law. And it is solid and it works and it makes accurate predictions time and time and time again. Otherwise it will be discarded. Theories can never turn into laws, just like a recipe book can never turn into the cakes that it's telling you the recipes for. So if you choose not to believe in gravity, fine, but please don't choose not to believe in gravity because a flat earther has told you that it's not a law or that it's only a theory. And if any flat earther uses that term that it's only a theory to you, just ask them, what is a scientific theory? And you'll be able to judge a lot about what they actually understand about the terminology they're using by how they can answer you. Do they stutter over the words? Do they know what they're talking about? Or have they actually got an accurate response to what a theory is? But anyway, there is a second reason flat earthers do not believe in gravity. So Rachel, I'm sure you know that the Cavendish experiment was that famous experiment that first managed to measure the gravitational constant. And what you'll find is a lot of flat earthers on the internet will just hand-wave dismiss it. They'll say that it can't be reproduced or that it was just totally flawed in some way. And those kind of responses are at the best misinformed and at the worst deliberately deceitful. I'm going to talk you through the Cavendish experiment and tell you exactly how it works and exactly how often it's been repeated and exactly how reliable that gravitational constant is. But first of all, we really need to start at what a constant is. I need you to understand why measuring a constant is really, really, really important and significant. Might get a little bit heavier than the rest of the video, but please stick with it. So this is the famous Archimedes, a truly brilliant mathematician who discovered principles that we are still using today. Now Archimedes was able to mathematically express the relationship between the area of a circle and its radius. Now obviously as the radius of a circle gets smaller, so does its area. But what he discovered was this proportional relationship, and by that I mean if the radius squared doubles, the area will also double. Now I suppose, if you like, we could consider that a law. Every time we take a circle and we double its area, the radius squared will also double. It happens every single time. But just knowing that this relationship is proportional doesn't help us if we want to calculate the area of the circle when we're given a certain radius. So for example, if I said to you the radius of this circle was 5 centimeters, can you calculate the area? Using this alone, you couldn't. But this is the power of a mathematical constant. You see, when we have two things that are proportional like this, we can find a number, a fixed number that never ever changes. We're going to call it a constant. Now, if Archimedes was right, and there is a direct relationship between the square of the radius and the area, whenever I'm given the radius of a circle and I times the square of that radius by a fixed number, I will find the area of that circle and I will be correct every single time, no matter what circle I am given. And of course that constant turned out to be about 3.14, and we call it pi, giving us that famous equation there, area equals pi r squared. And the point is this, pi is a fixed number, it never changes, but what it allows us to do is prove that there is a 100% definite link, definite relationship between the area of a circle and the square of its radius. So why is any of this important in any way, shape or form? What has it got to do with the Cavendish experiment? What's it got to do with gravity? Why am I telling you this? Well, observations had led us to very strongly believe that there was a proportional relationship between the force felt between two objects and the product of the masses of those two objects divided by the distance between their centre of masses squared. And this gave Cavendish the opportunity to look for a constant just like pi. Now remember, pi doesn't change. It is a fixed number. Whatever the radius of the circle, whatever the area of the circle, pi will always tie the two together, and it can only do that because there is a fixed and definite link between the area of a circle and the radius. That's what a constant proves, that there is a definite link between those two things. Now, this experiment gave Cavendish the opportunity to search for that gravitational constant, and if he could find it, then that would prove that there is a definite link between the force experienced between two masses and the masses themselves and the distance between them. So how did the experiment work? Well, this is how the equipment is set up, and what I've often heard flat earthers say is that they think all Cavendish was looking for was a movement of those two little green masses towards those bigger purple masses. And a lot of flat earthers seem to think if we spot that movement, then we are just assuming that that's down to gravity and that's mass attracting mass. Nothing could be further from the truth. And of course, if all you did was hang two masses like that and let the wind blow at them, it would be a pointless experiment that would do nothing. The fact that those weights would rotate on that string wouldn't prove or disprove anything. It would be the worst kind of science. And this is how a lot of flat earthers either understand or choose to represent the Cavendish experiment. And it really wasn't like that at all. Obviously, it wasn't like that at all. You see, in reality, what happens is once this equipment is set up and then shielded from any kind of outside interference, it is left to settle down. Once it has settled, that bar with those green masses on will start to oscillate. It will spin clockwise until the torque, the force on the wire, is enough to stop it, and then it will spin anti-clockwise again until the torque or that force on the wire is enough to stop it. Now, if that force that we have measured is proportional to the masses of those objects and the distance between them, then we should be able to calculate a constant number that, just like pi, will never have to change, even if I change the distance between those objects and I change the masses of those objects. The mass is long-winded, but ultimately this equation can be used to calculate that gravitational constant. But now we've measured the constant, that isn't the end of it, it's only the beginning. We have to make sure that this gravitational constant works, just like pi. You see, when we take a circle of any given radius and we square that radius, when we multiply it by pi, we will always get the area of the circle. Remember, because there is a relationship between the radius of the circle and the area. We don't have to change pi to make it work. So we have to repeat this experiment over and over and over and over again to see, do we have to change the gravitational constant, or does it remain fixed? You see, if there was no link between force and the mass of the two objects and the distance between them, then every time we did this, we'd come up with a different constant. And it wouldn't be a constant. There would be no relationship. And we'd have to discard it and say, there is no relationship between F and m1, m2 over r squared. And don't let flat earthers tell you that this experiment only happened once and has never been repeated or can't be repeated. You see, again, that simply is not true. This paper from just 2018 shows the results of 15 other attempts to measure the gravitational constant. And you know what's even more important than that? It's not just the fact that it's been repeated so many times, but it's been repeated with so many different versions of the experiment, so many different methods, all using different materials. A flat earther would like to tell you that magnetic fields or electric fields are somehow responsible for this sort of attraction. But when we're doing this test over and over and over with materials that have different electric conductivity, with metals that react differently to magnetic fields, and we're still getting the same constant, that totally rules it out as a possibility. In fact, if you were to look at the smallest number they recorded for this constant and then compare it to the biggest, you would find that the difference is smaller than this number. And I think that's pretty stunningly consistent. And don't forget that these very same formulas that we're using here also explain the movement of the planets in the sky. They explain the movement of the moons around Jupiter that you can see in this photograph. And that's not a coincidence that we're using the same gravitational constant and the same equations to predict the movement of the planets in the sky as we do to predict the movements of objects on Earth. If the flat earthers are right and this experiment was only produced once and it was unreliable, then what a coincidence that the result we got allows us to make all these amazing coincidences. So if you still doubt the Cavendish experiment and you've got questions on it, or another flat earther says to you that, you know, it was flawed in some way, just ask them, what is a constant? What is the gravitational constant? Why was it important? And again, listen to how they explain their side to you. Can they accurately tell you what a constant is? Do they understand what they're talking about? Or are they going to stutter and fall over the words and not actually be sure and try and change the subject immediately? Because yet again, that is going to tell you a lot about how confident they actually are in their own beliefs. And then we have Maskelyne's famous 1774 Schiehallion experiment. I'm aware that I've probably just pronounced both of those names wrong. Now, this was actually an experiment to calculate the mean density of the Earth, but putting that to one side, it involved hanging a pendulum next to a mountain and watching how much that pendulum was deflected from being plumb through mass attracting mass. Now, I've heard other flat earthers claim two things. Firstly, they'll claim that this experiment was crazy because how can a mountain, the gravitational pull of a mountain, outcompete the gravitational pull of the Earth? Well, you know, anybody that knows anything about just basic forces and physics knows that when you've got two forces that are at 90 degrees to each other, they don't interfere with each other at all. They act independently. There is no reason whatsoever that the mountain should actually be in competition with the Earth, with that pendulum. It just doesn't happen. And the second thing I've heard from flat earthers is that experiment just didn't happen. It was a lie. But for that to be true, yet again, we've just got to be completely ignoring events that happen in the real world. So, for example, in 2005, scientists from Glasgow decided, just for the sheer hell of it, to set up a competition and invite as many people as possible in a Weigh the World competition to repeat this famous experiment, which they all did. Now, we've touched on gravity a little bit there, and there is so much more we can talk about. But for now, if you choose not to believe in gravity, please don't choose not to believe in it. because someone's told you it's only a theory, or because somebody's told you the Cavendish experiment has never been repeated, or because somebody's told you the Cavendish experiment was somehow flawed in some way. If and when the flat earthers tell you that I am wrong and that the Cavendish experiment was flawed, just please do me a favour and ask them to expand on what they mean. Ask them, do they really understand the Cavendish experiment? Ask them what the Cavendish experiment entails. Okay, and again, you'll see by how confident they are in their reply and how much detail they're willing to give you, you'll see how much they actually understand. And maybe you'll guess whether they're just coming from a point of incredulity and personal belief. So right off the bat on the subject of gyroscopes, I think that I should mention the Netflix documentary Behind the Curve, in which Bob Nadell, a member of FE Corps, really wanted to get his hands on a fibre optic gyroscope. And he wanted to get his hands on a fibre optic gyroscope because they were meant to be sensitive enough to detect the rotation of the Earth, a 15 degree per hour drift. But Bob and FE Corps were convinced that once they did get their hands on one and they turned it on, they would show that it measured no drift whatsoever. So all was going well. They had their hand on a fibre optic gyroscope, and what did it show?
A 15 degree per hour drift.
They showed out Bob for 15 degree rotation, but they never actually asked his side. I asked his side, and after that show he did another test and he got more than 15 degrees with elevation. So it doesn't work on the globe. So
now, I don't know what to say on this other than he wanted to get his hands on a fibre optic gyroscope. He got his hands on a fibre optic gyroscope and it gave him the one result that matches perfectly with the globe Earth. If that piece of kit was flawed in some way, it could have given him any result between 0 and a million, but it gave him the one exact result that would match with the globe Earth. He then admitted on camera that he wasn't going to release that data. You can go to the FE Corps website and you can see other experiments like the long-range microwave tests that they've done that they are withholding the data for. They are not releasing the data for. And then for him to claim that he's taken this piece of equipment and taken it up a mountain and repeated the test and got a slightly different result. Again, well, we can't see the data and we can't see how he's calibrated it and we didn't see the experiment live. No. And unfortunately for him, he just isn't the only one. It's just a fact that there is equipment out there now sensitive enough to measure the rotation of the Earth, and that is what we're measuring. And if Bob was claiming that this was some sort of error on the part of the equipment, isn't it a really, really massively curious coincidence that the exact reading he got from a broken piece of equipment was the exact 15 degree per hour drift that will be predicted on a rotating Earth?
they say, well, Bob's wrong because airplanes have these gyros in them and they pick up the 15-degree drift, but the gyros are meant to pick up rotation of what they're on, I believe, or I'm not even sure, but if it can pick up the air, then it can pick up an ether. If it picks up what it's on, then it won't pick up the air, because even if you want to say the air is spinning with the same momentum as the Earth and friction's causing that, and
so Bob's claim that the fibre optic gyroscope might actually be picking up a 15-degree per hour rotation of the ether doesn't match at all with his previous claim that the fibre optic gyroscope wasn't working or wasn't properly calibrated because he was picking up different results from the top of a mountain. Which one is it? Is he getting a 15-degree per hour drift or is he not? And if he is getting a 15-degree per hour drift and he's claiming it's the ether, then what evidence is there for that? Because all other attempts in science ever to measure some sort of movement between the Earth and an ether, like the Michelson-Morley experiment, have failed to show that the Earth is moving through some kind of ether. So is Bob Nadell claiming that a piece of kit, a fibre optic gyroscope that he didn't even build, that was just given, somehow has these magical properties to do stuff that all of science in the past has failed? It doesn't really ring true to me at all. But anyway, that's enough of fibre optic gyroscopes.
Earth rotation, and then it'd have to be like 15 degrees. Sorry, pardon me. 15 degrees in each axis.
No, that's actually not true. This is a gyrocompass, incredibly important pieces of equipment. You'll see why in a minute. And it has three axes, a horizontal axis, a spinning axis, and a vertical axis. Now, if the Earth was a globe and we placed one of these at the North Pole and one of these at the equator, they'd be at 90 degrees to each other. And if the Earth was flat, it wouldn't matter where we placed them, they'd always be the same way up. Now let's go back to the Earth and allow the Earth to rotate. Now if the Earth was a globe, the gyrocompass at the North Pole should be displaying a 15 degree per hour drift around its vertical axis as the Earth spins beneath it. But the gyroscope at the equator shouldn't be showing any drift whatsoever around its vertical axis. Now a gyroscope placed somewhere in between the two will be showing some drift, but the amount of drift should be predictable and calculatable depending on its latitude. Now if the Earth was flat and non-rotating, we shouldn't be seeing any movement at all from the gyroscopes. But if the Earth was flat and rotating, we would see movement across that vertical axis, but we would see it the same in every single gyroscope on the planet. So if the Earth was a globe, the gyrocompass would behave in an extremely predictable way, depending on where it was on the globe. The different amounts of tilt and drift on the axis would be an excellent indicator of where we were, and it would make it a fantastic tool for navigation. Whereas on the flat Earth, these gyrocompasses would behave the same no matter where they are. And the reality of the situation is, they do work. Welcome to Solace. Solace are responsible for the safety of life at sea, and please let this quote sink in. The Solace Convention in its successive forms is generally regarded as the most important of all international treaties concerning the safety of merchant ships. So the Solace Convention isn't a joke. It's there to save people's lives. It's there to save the lives of people who are at sea. It's not part of NASA. It's not there to generate millions of pounds for the government. It's not part of some wider conspiracy linked to other networks that have anything to do with space travel. It is there for sailors and people who go to sea to save their lives. And in the Solace Convention, Chapter 5, it lays out the mandatory use of gyrocompasses on all ships larger than 500 gross tonnage. And it does this because they work. It does this because we do get different amounts of drift across each axis depending on our latitude. It does this because the Earth is rotating. It does this because the Earth is a globe. Now, will you see people on YouTube that have their own gyroscopes that fail to pick up the rotation of the Earth? Well, of course you will, because they've bought gyroscopes affordable to the likes of me and you, which just, simply put it, aren't sensitive enough. There is too much friction in those cheaper made gyroscopes to pick up that 15 degree per hour drift. It's as simple as that. But these things are out there, and Bob Nadell and the FE Core team can go and buy one and try it just like they did with the fibre optic gyroscope. And just a final reminder that these things aren't made by NASA or some government-owned corporation. These are made by private engineering companies. And all of those private engineering companies say the same thing. Their gyrocompasses operate because of the rotation of the Earth and because of gravity. And remember, they work on those principles so well that they are compulsory on larger ships because of the Solace Convention.
As the sun gets closer, so distance-wise, as it gets closer, it appears higher in the sky, so it's sunrise. As it starts to get further away in distance, it appears to lower in the sky, sunset.
Okay, so I have heard this argument before that sunrise is just nothing more than the sun moving towards us and getting bigger and brighter in the sky, and that sunset is nothing more than it moving away from us once it's got to us, again getting smaller and dimmer in the sky. But let me ask you this, okay? Just watch this clip. Okay, so in that time-lapse video there, exactly at what point of that video does the sun look like it's moving towards you and then away from you? Because from where I'm sat, it looks like it's just doing that in the sky. It doesn't look like it's coming to me. It doesn't look at all like it's going away from me at all. See if you can just watch it again just one more time. Pause the video and really try and be honest with yourself and ask yourself, does it really look like it's coming towards me and then away from me? Really? Now, I'd say at no point in that video does it look like it's moving towards me and then changing direction and going away from me, or moving towards me and then passing overhead and going in that direction. And I think you know, and you've seen that when people film the time lapse of the sun using a solar filter to cut out the glare, the size of the sun doesn't change. It's not getting bigger as it moves towards. It's not getting smaller as it moves away. It's keeping the same size all of the time. None of the observations match with the idea that the sun is moving towards us or away from us. But on top of that, ask yourself these questions. I don't think anybody's going to deny the fact that we can wake up tomorrow and watch the sun rise, we can watch it move through the sky during the day, and we can watch it set. But given the fact that you've said you don't believe in rotation of the Earth, you don't believe in gravity, then what force is it that is somehow making the sun keep revisiting us day after day after day after day? You see, even if you choose not to believe in gravity, that doesn't stop the fact that that sun is coming back day after day after day, and it's not falling out the sky. So we have to take everything we know, gravity included, push it to one side, and then we have to come up with another reason that might be happening. Now, please ask yourself, what is more likely? Is it more likely that all of science, all of government-funded and private industry science is completely wrong, and this force out there has eluded them, and they don't even know it exists? Or is it more likely that a handful of people on YouTube who, for whatever reason, choose to believe the Earth is flat are just saying gravity doesn't exist because they need it to not exist for their belief in flat Earth to be real to them? Especially when you ask those people to describe things like the Cavendish experiment and the flaws in it, and they can't. And it's not just that. I mean, what stops the sun, and the moon for that matter, just falling out the sky? If it's all down to density, are we saying that the sun and the moon, this solid looking moon, are less dense than the air? So Rachie, please think about this. Please look at the moon. Look how solid it looks. Think about the argument of density versus gravity. Think about being told by flat earthers that things fall, not because of gravity, but just because they're more dense than the surroundings. And look at that hard, solid, huge rock-looking moon and ask yourself, why does that not fall out the sky? Is there yet another unexplained force that we have to just invent? Do we have to start to pretend to know even less and less and less for this flat earth thing to make any sense? And we've got to remember as well that if the sun is small and local, like a lot of flat earthers say it has to be, then we'll be able to view the sun from lots of different angles. And that causes a massive problem. When I used to teach astronomy, we had a solar telescope, and the kids used to be able to go out in the daytime and look at the sunspots on the sun. Anybody can do it, anybody can buy one. And over the weeks, the sunspots will move across the surface of the sun. But if people on Earth were viewing the sun from different sides, on any given day, in any given moment, people will be seeing different formations of sunspots. You see, viewing from the side of the red arrow here, we'd be able to see the sunspot. But viewing from the back, from the blue arrow, we wouldn't. But that isn't what happens. On any given day, anybody who can see the sun will see the same formation of sunspots. And it's exactly the same with the moon. We all know that we all see the same side of the moon all the time. But as only a globe will predict, as we move ourselves from the northern hemisphere to the southern hemisphere, the moon appears to turn upside down. And what about the weather? I mean, if the sun is actually getting closer to us during the day and then moving further away from us, where's our massive spike in temperature that we'd expect? It just doesn't exist. And finally, while the sun is setting, if it is setting just because it's moving further away from us, why can we not then bring it back into view after the sun has just set? Why is that impossible? And why, when it does set, does it seem to disappear at different rates? Why does the top of it maintain its normal size, yet the bottom of it shrink as if it's moving really far away from you? None of that seems to make sense. And how is it possible, if the Earth is flat, that every single evening, when the sun sets, we always see clouds illuminated from the bottom? At what point does the sun descend to become lower than the clouds if the Earth is flat? Or is it just more likely that the rotation of the Earth has put the sun from our perspective below the horizon? And we could go on and on and on about the sun, but I think for now, that's enough.
Jeranism. Everybody always talks about this Jeranism experiment as well on the Netflix.
Now, for those of you who aren't aware, Jeranism is another popular YouTube flat earther who is in the same Netflix documentary as Bob Nadell that we mentioned earlier on. And this is his experiment.
If you're seeing through this hole, through the next hole, and seeing the light at the backboard at 17 feet off the water, the Earth is flat. If he's holding it up at 23 feet high and we're seeing the light, well, that's because the Earth's curved. So I should only be able to see it when it's at 17 feet.
Now, we all know how that ended. The result he got was exactly the result that he would have expected to get on a globe. And I really want to hammer this point home. Please, Rachel, think, what are the chances of two flat earthers giving their best experiments because they know they're going to be on a documentary, doing their best planning and creating their best experiments for this documentary? What are the chances of them doing that and then both of them, by complete chance, getting the results that exactly match what we predict to happen on a globe? If Bob's experiment was flawed or Jaren's experiment was flawed, we could have got results that show all sorts of different things, but we didn't. They both produced exactly the same results that we would expect to get on a globe. What are the chances of that? Now, sure, afterwards they decided that, oh, they didn't have faith in their results, that, you know, there must have been some kind of flaw. But again, ask yourself, is that the likely thing that's happened? Or is it more likely that they have a deep-rooted belief in flat Earth and they are that far down the rabbit hole, they just refuse to accept the evidence that they've been presented with?
And from my point of view, how I see is things lower with distance. So, being that things lower with distance, they're no longer going to be the same level as things lower with distance. So, he's going to need to lift it higher because things appear lower. So let's say this one's appearing lower with distance. He's going to need to lift it higher to then be seen.
So I have heard that before, that when things go into the distance, they appear lower. Yeah, fine. But listen to this. Let's take a bridge, a flat bridge, and look at it from a distance. Now on that bridge are two identical twins, and when they are stood next to each other and they look at each other, they can see they are the same height as each other. Now if they were both to walk away from each other and look at each other when they were stood at opposite sides of the bridge, they may look smaller to each other, but if anybody was stood next to them measuring their height, of course they're going to be exactly the same height. Now let's imagine that they're both holding the opposite ends of a steel rod at the height of their own hip. Whatever it looks like to the brothers when they look at each other, it's very, very clear that the height of that rod isn't changing or lowering at one end. The physical height of that rod is going to be the same height above the bridge for the length of the bridge. Now let's substitute that metal rod for a laser or a ray of light, and we'd have exactly the same effect. We'd expect that laser to be at exactly the same height over the bridge at every single point, no matter how much smaller due to perspective the other person might look. So just to be clear, even though one of the twins may look smaller to the other one, nobody expects that this on screen right now is what's happening. Nobody expects that to actually make a difference to the physical place that that light beam is coming from. Now let's compare that to Jeranism's experiment. Now let's be painfully clear on this. Jeranism is saying that the Earth is flat and that these two holes in that piece of wood are the same distance from the ground. When Jeranism can see that light source, that means 100% that the light must be travelling in a straight line through both of those holes, just like this. But the claim that this doesn't work because when you go further away you appear lower means he's actually suggesting this. He's actually suggesting that the torch is physically closer to the ground, just like we saw with the two boys on the bridge. And if that's true, then everybody around the person holding the torch is going to be screaming at that bloke holding the torch, why are you not shining it through the hole? Why are you shining that torch at the bottom bit of the wood? Surely the simplest thing the guy holding the torch could get right is to actually hold it next to the hole. Or maybe he was trying to shine it at the hole, but for some reason that plank of wood with a hole in front of him he didn't realise had grown 6 foot and he had to point his torch upwards. And then nobody noticed when he held the torch in the air that he didn't need to angle it upwards anymore. He could point it straight through those holes. To be really clear, when he makes this excuse, he's asking you to believe that when he sets up a torch that is 17 foot from the ground in one location and then walks away from it, as he walks away from it, that torch is going to magically reduce itself to 11 feet off the ground without anybody stood next to the torch actually noticing. And I think the important thing is, if you actually ask Jeranism to properly articulate and explain what he means when he says he got those results because things appear lower when they're in the distance, if you actually asked him to take diagrams like I've just done and explain to you exactly what is going on with that ray of light, you'll find that he won't do it, and he has never done it, and nobody will ever do it. It seems that the arguments are just reduced to sound bites, like things get smaller as you go further away.
So people ask, why do things float in the sky? Could be so many reasons. I did think alternating currents, but people said they would be able to detect that, so probably not. And I have thought maybe, because we know sound waves can levitate things, and they've apparently sent these probes up there and they can hear like sounds coming off planets and things, so maybe there's sound waves up there. Well, not necessarily waves because there's no medium to travel through, but maybe there is a medium kind of it, or a field, and these frequencies cause interactions with this field and cause them to levitate and move. I don't know. I'm just spitballing.
And I agree, we do have to spitball about that if we are going to remove gravity from the equation, because gravity is the reason things behave as they do in the air and the water. Gravity is the reason that more dense things sink and less dense things float. And without gravity, there is no workable explanation. Think about all the different explanations that flat earthers have tried to offer you. And just remember that not one of them has stuck, because every single one is so easily disproven. Now, we have spoken in the comment section in the past about density and gravity, etc. And there was a little bit of cross wires and miscommunication. So I'm going to try and simplify that for you a little bit to try and highlight the point I've just made. Let's take a ball, a big, heavy, solid ball. And now we've got the ball, let's put someone in the picture who's going to try and move the ball. If he wants to push it this way, he has to apply a force to the ball. He has to physically push the ball. We all know that. Same if he wants to push it this way, he's got to apply a force to it. And he has to apply a force to it to push it this way. We know for a fact that when we want to change the motion of something, we've got to apply a force to it. It's in fact one of those laws we talked about earlier on. It's Newton's first law. When I want to drop something, all of a sudden, I don't need to add a force to it. I don't need to apply any force to something just to let it go and watch it fall. So given that we know we need a force to move the ball, and the ball is still moving in that downward direction, then that force must be being applied by something in that downward direction. And flat earthers would like to tell you its density. But let's examine that claim. Now this ball is going to start sinking through water, and we could have used air as an example. It's the same principle. But as it sinks through the water, it has to push the water in front of it out of the way. In fact, this ball, if it's going to totally sink, has to push away this amount of water. And it pushes that water out in all directions. And if that water is in a cup or something like that that's quite full, and you drop a pebble in, you'll see water splashing out the top. So where does this force come from? How is this force generated that's allowing this ball to physically push water out of the way? Well, gravity is clearly the answer because it predicts perfectly the behaviour of that object. But does density? Well, this is the equation we talked about before for the gravitational force, and this part of the equation here represents the 9.8 meters per second squared acceleration that you talked about before. So another way of writing this equation is force equals mass times acceleration. And not only can we use this to accurately predict the force with which that object is falling, but we can use it to predict the speed it's going to be travelling at when it hits the ground from any given height. This is the equation for density, and it doesn't allow us to calculate anything other than the density, mass and volume of an object. Nowhere in our understanding of density is there any link whatsoever to force or acceleration. Nowhere in the entire scientific world's understanding of density is there any link between the density of an object and its ability to suddenly move and accelerate on its own. Now, I'll go into that in a little bit more depth in a second, but for now, I just want to say that I've been teaching science for just over 20 years now, and I know literally dozens and dozens, if not over 100 other science teachers who all know the same number of other science teachers, who all know plenty of people at universities. We've all read, between us, thousands of textbooks and scientific papers, right? Everything out there tells us that we all have exactly the same understanding of density, and that is, it's just a property of something like length or colour. Nobody out there in academia says that density somehow has the ability to make something move. Just like nobody would say the fact that something has a particular length is going to make it move and jump in length order with other pieces. It just doesn't happen. And again, please ask yourself, what is more likely? Is it more likely that everybody who's gone through school and university and studied and learned and applied this stuff and gained an understanding of it, is it more likely that they are wrong and actually density does have this magic property that just makes things jump into some sort of order without any external force? Are they wrong? Is it more likely that, again, a handful of YouTubers have got it cracked? I don't think so. Now, in the past, we have talked about the aircraft carrier and the bowling ball on a set of weighing scales to show that density can't be the reason things fall to the ground. But I think I've got an even better analogy now. And that's the analogy of ice on weighing scales. Now ice is slightly less dense than water. It's got a density of around about 0.9168 grams per centimetre cubed, and of course it keeps that density no matter how big or small the piece of ice is. So if I was to take a small cube of ice, let's say 1 centimetre cubed, it would have a mass of 0.9168 grams. Now if I took a much bigger cube of ice that was exactly 1 metre cubed in volume, it would have a mass of 916.8 kilograms, a million times bigger mass. Now if we took these two blocks of ice and put them on some balance scales, we know that that scale wouldn't balance. We know it's going to tip to the side of the larger ice cube, the one that has a mass that's a million times bigger than the other. The fact that they're both made of ice and they both have exactly the same density makes zero difference whatsoever to the result we're going to expect. And don't forget that that larger ice cube also has to provide the force to push out much more air than the smaller ice cube. Now if density was the only reason that these ice cubes would sink through the air, then this scale should be balanced given that the density of the ice on each side is the same. So like I said, there's zero reason to believe that density itself is the cause of anything. Of course density is important, but without that external influence, without that external force, we're not going to get things floating and sinking, and we're not going to make the observations that we see in the real world. And what about this tennis ball? Are we meant to believe that the bottom half of this tennis ball is somehow more dense than the water around it, but the top half of the tennis ball is less dense? Or does it just make more sense that once a tennis ball has submerged itself this far, that the force of gravity or the weight of that tennis ball pulling down is now equal to the force it takes to displace that amount of water? In other words, once again, gravity and buoyancy working in a manner that is 100% predictable. That's why we can build ships like this. Our understanding of gravity and weight and buoyancy makes feats like this possible in a way that this equation here can't even begin to ever dream to. Anyway, one of the things that motivated me to make this really long video was what you said next.
There's some things that might be questioned flat earth though, and if any flat earthers do know the questions, I'd be happy to hear them. So things like how the moon illuminates.
So how does the moon self-illuminate? Which is a question that you can only ask yourself once you've eliminated the idea that the moon reflects light from the sun, which is something you have to do if you're going to be a flat earther. But even then I think it's the wrong question. I don't think we should be asking, even in that position, how does the moon self-illuminate? I think we should still be asking, does the moon self-illuminate? Again, when I used to teach GCSE astronomy, one of the pieces of coursework that the kids had to do was look at the moon, choose an area on the moon and monitor it for as many nights as possible as the terminator, the shadow line, moved across the moon. The idea was to look at how the detail of the craters changed. Now this is something that thousands and thousands and thousands of kids who were all doing that course each year did. And they did it with fairly cheap telescopes and binoculars. It's not a difficult thing to do. And we all saw exactly the same thing, that these craters get filled with shadows and these shadows move. Now, how can a self-illuminating object have shadows cast upon its surface? The only way you can cast a shadow upon the surface of the object is if the illuminating source, if the light source is external. It simply can't be the moon illuminating itself, unless a flat earther on Earth can maybe show me a light bulb that lights up and casts shadows upon itself while it's lighting up. It just doesn't make sense.
There's another one, the two star rotations.
So, two celestial poles seemingly rotate in opposite directions when viewed from Earth is a great piece of evidence for a globe Earth. And the best I've ever seen a flat earther come to try and answer this question is to draw some stars on a piece of paper and put some sort of a lens over the top. And as they rotate the lens or rotate the paper, it seems to create some kind of swirling, turning effect. But none of these weird, unscientific, putting a lens on a piece of paper models ever holds the positions of any of the stars relative to each other. What that means is it will be impossible to have fixed patterns of stars like constellations in the sky. These constellations that we actually see in the real world night after night after night. But you see, it's not just about the celestial poles, it's about how accurately we can use a globe Earth idea or a flat Earth idea to accurately predict the movement of the stars in the sky. Only a globe can accurately predict time and time and time and time again what stars will be circumpolar from which latitude on Earth. So if we know the declination of a star and we know our latitude, we can calculate whether or not we should be able to see that star dip below the horizon or not. And as you've probably guessed, this works and we can. And yet there's absolutely no model, no explanation, no even attempt at an explanation on how to do this on a flat Earth. Sextants were navigational tools that we can use to find our position, and one of the ways we can do that is by measuring the angle to Polaris in the sky. Now, the position of Polaris in the sky will change very, very differently on a globe Earth as it will on a flat Earth, and people use their measurements taken from these sextants and apply them to the observations we would only expect on a globe Earth to try and navigate the way around the globe. And did they work? Did people get lost? Well, sextants have been around since the 1700s and they are still being used today to successfully navigate people around the Earth. If the Earth was flat, then the calculations made from the readings on a sextant will be getting sailors lost all over the place, left, right and centre. But it stood the test of time. It works. Now, I know as I've been making this video, you've been leaving a couple of questions in the comment section that we've been sharing. And I am going to get to those questions in a second, but for now, seeing as we're on the topic of things that the flat Earth can't answer, I've clipped this from another video I made for a video on my Baldy Cats channel, and I think it might just fit in well at this point. See what you think.
Let's look at predicting the weather. The weather is predicted by meteorologists who use satellite imagery of a globe to do it. No meteorologist on the planet has any idea how to predict the weather on a flat Earth. They don't know how it's done. But if the Earth is flat, that means somebody has figured out how we predict the weather, because we do predict the weather. But then they've also managed to infiltrate every single company in the world that has anything to do with predicting the weather. However, the people that work in those companies have no idea that this is happening, because all the software and all the ideas that they're using are based on a globe model. Amongst many other things, seismologists can accurately locate the epicenter of an earthquake. But they have no idea how to do that on a flat Earth, because they use a globe Earth model and the movement of seismic waves through a globe Earth to make those predictions. But they do find those epicenters. They can do it. So if the Earth is flat, that means that somebody has figured out how to predict the epicenter of an earthquake on a flat Earth, and then infiltrated all the independent seismologists across the entire world, and then somehow brainwashed them into thinking that the calculations they are doing are actually based on a globe model, when in reality they're based on this secret science on how to find an epicenter of an earthquake on a flat Earth. The most efficient flight path from one country to another is calculated independently by independent airlines all over the world, and they use a globe model to do it. However, if the Earth is flat, what that actually means is somebody has cracked the idea of how to calculate these most efficient flight paths based on a flat Earth, and then somehow infiltrated all these independent companies all across the world and brainwash the people doing these calculations to make them believe that they're doing these calculations based on a globe model. On planet Earth, there are literally thousands of independent companies that send radio signals and TV signals, and they all seem to be under the impression that when they send their signals, if they send them in a straight line, they don't really travel much further than 40 miles because the curvature of the Earth is in the way. So they have to use frequencies which will bounce off the ionosphere and allow those signals to travel further around the curvature of the Earth. Now, if the Earth is flat, what that means is somebody has broken the laws of physics and somehow stopped these TV companies sending signals further than 40 miles, but then infiltrated their equipment to allow the signals that they send off the ionosphere to travel much further. This is an equatorial mount. You can use it to track the sun as it moves across the sky. However, the people that design the equatorial mount and sell them independently to make money for themselves and their families have designed the equatorial mount based on a globe Earth. The equatorial mount itself cannot physically rotate in the way that's needed for it to track the sun over a flat Earth. So if the Earth is flat, what that means is some flat earther has been able to infiltrate all the equatorial mounts on the planet and somehow adjust them slightly so the designers of them can't notice those adjustments, but now they do work and track the sun on a flat Earth. This is a TARDIS. It allows a user to travel through space and time. And if the Earth is flat, then the people organising the conspiracy must own a TARDIS. And the reason for that is, any kind of conspiracy to hide the true shape of the Earth must have been hundreds of years in the making. Meaning that this conspiracy was well underway when there was no emails, when there was no mobile phones, when communication between different countries was almost impossible. And yet somehow the people behind this conspiracy to hide the shape of the Earth were simultaneously, at that time, manipulating people across the entire plane and somehow ensuring that all these different populations reach the same false conclusion.
Now, I have many times put these questions to flat earthers and I always get 3 responses. The first one is no response whatsoever, and that's the kind of response I usually get from the big well-known flat earthers like the Jeranisms and the Mark Sargents and the Eric DeBays out there. They seem to either conveniently not read the messages or read them and decide not to answer. The second answer I get from flat earthers tends to be, is that the best you've got? And the third answer I get from flat earthers is, I need to go and do my own research instead of bugging them with questions. So next time you are talking to a flat earther, please ask them some of these questions. and look at the response that you get from them. And if that response is dismissive and it seems as if they're totally disinterested in even trying to investigate what the answers to those are, again, that gives you a real indication of how serious they are about the beliefs, how seriously you can take everything else that they're telling you. Anyway, for now, I have somebody very important that I want to bring on to give you a little bit of a message.
Wow, thank you so much, Conspiracy Cats. That breakdown has been amazing. I've learnt a lot myself there. Rachie, hopefully you've got this far. It may take a few times to watch this video. Please do so. I know 100% that you are a genuine truth seeker. There is an ego involved and mental blocks that will not allow flat earthers to accept evidence. From the start, we are made to believe that no evidence is sufficient to prove a globe, when there is hundreds and hundreds and hundreds of ways. I have a part 2. It will not be a breakdown of your video. Conspiracy Cats has done such an amazing job and I cannot thank him enough. But please everybody, after this video I will have a part 2 where I will go into more about what I believe the constraints that flat earthers are under, which makes them think that they cannot be wrong. And this is what it is all about, is an acceptance that we might possibly be wrong about our choice in believing in flat earth. If you can get yourself to that mindset, open-minded, you will realise and understand that there is no flat earth. We do have measurable rotation and measurable curvature. Any excuse is made to make it seem implausible, but so many people would not be wrong about such a big thing. I'm now going to hand over to Professor Phil Bell, as I understand you and him have communicated as well, and I please hope you appreciate the effort that has been put in to trying to help you. We are doing our best because we can see that you are genuine. There are a lot of people out there that are not genuine flat earthers, but you do not come in that category. That's why we want to help people like you see reality and see our universe for how beautiful it is. Over to you, Professor Phil Bell.
Hi Rachie, it's Phil. As usual, you've asked some great questions, and Conspiracy Cats provided some great answers without his usual humour thrown in for good measure. That's because he took your questions seriously, just as I always do. Now, Rachie, we're both educators, and what we both love doing above everything is explaining science and mathematics to others. So you'll never find people like Conspiracy Cats trying to lie to you or provide an explanation for something he knows is incorrect. So one of the things we hear often is that teachers like Conspiracy Cats just repeat what others have told them. Well, Rachie, nothing could be further from the truth. Conspiracy Cats would have studied science at university, and without doubt, all of the assertions that he would have come across would have been backed by evidence and underpinned by years and years of investigation and predictability. If there's one word you could take from the answers Conspiracy Cats gave you, and that's the word prediction. So prediction is the cornerstone of what makes speculation different from fact. When time and time again you can make extraordinary precise predictions based on your explanations, you can be pretty sure that it's right. Now, Rachie, contrast that with flat earth explanations and speculation where not a single thing is verifiable or has any utility whatsoever as a means of predicting anything. Surely that must say something to you. Look, no doubt, having gone through the video, you probably have even more questions, and that's how it should be. So, in the meantime, think about this. If you were to choose a position where you would begin your search for truth, why would you not choose one with almost 100% correct predictions, where you don't need to ignore or deny facts? Nobody is lying to you. Or would you choose a whole lot of conspiracies? All sorts of conspiracy theories. Scientists and engineers are all liars or fools. No models, no maps, no coherent explanations that can ever make accurate predictions. Is that what you'd choose? Look, we live in such an exciting time, with science making leaps and bounds. All of that based on the centuries of work that came before us. Look, I'm sure you'd love to join with the rest of humanity and enjoy the discoveries that happen so often. So, keep asking the great questions, Rachie.
Professor Phil Bell, thank you so much for that. Now, Rachie, on to the rest of the questions that you give me. I think I've got 2 of them. Here's number 1. So the first question you wanted to ask was, is the horizon geometric or physical? So in other words, when we're actually looking at the horizon, is it actually there in that position, or is it in a slightly different position due to refraction? Okay, now the answer to this question is fairly simple, but the first thing I want to say is please be careful of sound bites and things you might hear on channels like the Flat Earth Debate channel that are not out there to actually have a discussion and have a debate. They're out there to lay traps that allow people to scream and shout and walk away and claim that they're a winner. For example, this is a classic Nathan Oakley pointless, totally pointless question, which we'll see in a minute. And essentially what Nathan Oakley wants you to do is either say, it's a geometric horizon, in which case he can instantly shout over you and mute you by saying, well, if it's geometric, you've lied about refraction. Refraction doesn't exist. Or he wants you to say it's some kind of optical horizon because of refraction, in which case he can instantly mute you and shout over you and for some reason say, well, that means it's not geometric, so it's not possible for a ship to go over it. And that's what he wants to say. And neither of those comments make sense whatsoever. I hope this clears it up. So let's see if we can clear this up a little bit more honestly than somebody like Nathan Oakley would. Look at the trees through the lenses of those glasses. And ask yourself, do those lenses of the glasses refract the light in any way? I think the answer is yeah, of course they do. Now if I was to tell you that there's a squirrel hidden behind this little stump of a tree here, Nathan's argument will be, well, that is impossible. And he'll say it's impossible because that tree trunk actually isn't there. Because of refraction, we're not seeing a geometric position, we're seeing an optical position. So how could a squirrel possibly be behind that optical phenomena? And if you said, okay then, there's no refraction happening through the glasses, he'll then say, oh, well, you're a liar then, because you said refraction is a real thing. And that's his technique. It's an extremely dishonest one. Now, the bottom of boats like this, which we see all of the time, consistently, every single time we watch a boat sail away from us, every single time we see this. And the bottom of the boat is like the squirrel behind that little bit of the tree trunk. And if people want to say, because of refraction, where we're seeing the exact position of that waterline is not exactly where it is in the real world, well, the same applies to the boat. What's important is the relative positions of the two. And the bottom of that boat is clearly behind the water, just like the squirrel would clearly behind the tree trunk. And if you're not sure how much refraction's at play, look at the boat, or in this case, look at the oil rig. The famous black swan photograph. That oil rig on the left looks like it's melting in the heat. So a good rule of thumb, from me to you, is the less distortion in the picture, the less refraction and the less optical effects are taking place. So, next question. So this question here was about sea level, and you were saying that if the sea level is supposed to be the same all over the Earth, then how can it be if the Earth is a slightly oblate spheroid? Shouldn't the sea level at the equator be different to the poles, etc.? And this really is a complicated answer. However, the most basic answer I can give is that the sea level isn't level all over the Earth. The sea level does change at different points over the globe. Mainstream science just doesn't say at all that sea level is constant all over the planet. Things like local differences in the strength of gravity at different points on the Earth, the salinity of the water, temperature, all have an effect on sea level. Now, I know you know who PhD Tony is. In fact, you even mentioned him and give him a shout out in this video I'm responding to. He's an extremely intelligent individual, and he is by far the best person to answer this question. His job is to understand sea level and sea level changes. So I think I'll be doing a massive disservice if I didn't say, go and contact PhD Tony. I know you know how to. And have this conversation with him, and I'm sure he'll be more than happy to help and give you a little bit more information. I'm done. Now, at the start of this video, I did say that I wasn't going to be able to change your mind, and I stand by that. I'm not going to be able to change your mind. Obviously, only you can do that by weighing up the information on both sides. At best, I hope I've given a spoonful of information, some of which you might not have heard before, just to add to that pile while you're evaluating it. But I will urge you just to answer this one question, or think about it. Does one side of the argument seem to present clear, logical, articulated explanations for the observations we see around us? And does another side of the argument seem to have nothing but sound bites and things that are incapable of making predictions? Does that other side of the argument seem to need multiple different explanations for the same phenomena, all of which that contradict each other? And more importantly, does that other side of the argument get supported by people who can't explain concepts like, what is a constant? Ultimately, for me, if you start off on a blank slate and you look at the science, the Earth is a globe. If you start off believing that the Earth is flat, then your only option is to deny science, call people liars, and just invent stuff that has no back into it whatsoever. Anyway, good luck in your journey. I hope that I speak to you again in the comment section. And yeah, peace.